Hello, everybody. My name is Ioannis Hadjiouannou. I'm a postdoctoral researcher within the National Technical University of Athens. And today I'm going to share with you one of my latest research that is almost ready to be sent to an academic journal. Of course, there are some minor details missing. The work is called the Composite Index for Assessing Sustainable Mobility in Urban and Rural Areas. And okay, let's start. The actual transportation system is a system that heavily prioritizes private automobiles with all the associating negative externalities of transport, such as road crashes, congestion, local air pollution, noise pollution, greenhouse gases, etc. For this reason, there is the need to move to a paradigm shift, going from the traditional capacity paradigm that is based upon the increased road supply and has as an effect the induced traffic, to a sustainable mobility paradigm that stimulates the change towards sustainable modes of transportation and set up the base for an inverse mobility pyramid that has on top walking, cycling, and public transport, and at the bottom private cars. Nevertheless, this situation generates an important question. How we are going to monitor sustainable mobility, how we are going to measure it, and how we are going to define the targets of the whole planning process. The answer is through indicators, either quantitative or qualitative indicators, but that generate and that can be used in different scales, etc. But this has as a result the generation of a babel of mobility indicators that exist within the same country. So, in search of a common language to be spoken by all mobility planners, we can move to the sustainable urban mobility indicators as they have been established by the European Commission. And based upon that, this study aims to establish a framework to assess and quantify sustainable mobility, prioritize sustainable urban mobility indicators via data-driven approaches and participatory elements, and to implement them in 4 Greek municipalities, namely Egaleo, Nafplio, Nea Smyrni, and Xylokastro. Okay, the sustainable urban mobility indicators can be located within the 3 pillars of sustainability. We have the affordability indicators that is based with the cost that the people need to pay in order to make use of public transport. The accessibility that determines the accessibility of public transport services to people with reduced mobility. The air pollution emission, along with noise pollution. Road deaths that can be translated to transport accidents in the urban area, in the area of study on a yearly basis. Mobility share services, that is the share of population with appropriate access to mobility services. Greenhouse gases emission. Traffic congestion that can be translated to delays in road traffic in public transport during peak hours compared to off-peak travel. Energy efficiency, that is the total energy used by urban transport per passenger and kilometer. The active mobility that is associated with the new infrastructure or the existing infrastructure for active mobility, namely walking and cycling. Multimodality that takes into account the existence of different modes of transport and the interchange of them. The satisfaction that the people have using public transport within their area. And finally, the fatalities is the active mode safety, that is the fatalities of active modes users in traffic accidents within the city in relation to their exposure to traffic. These sustainable urban mobility indicators, we're trying to implement them. In fact, we did it. We implemented them in these 4 Greek municipalities that is called Galeo, Neas Myrni, but they are within the metropolitan area of Athens and can be characterized by having metro and tram and bus lines, cycle lanes, and green space and squares, along with being, in the case of Galeo, being a bus feeder lines and having heavy through traffic flows. We have also Nafplio, that is, it was the first capital of Greece, let's say. It can be characterized by bus lines, pedestrian zones, green spaces and squares, and Xylokastro, that has a lot of tourism during the summer time. Okay, and let's move on to the data collection. Let's see the sources that we based our data collection. The first one was Elstat, that is the statistic authority of Greece. And we received variable information, variable data for most of the sustainable urban mobility indicators seen before. The interviews with public transport operations, where we considered information such as the number of vehicles qualified as accessible, number of stations qualified as accessible, the departures per hour, the list of interchanges, etc. The next one is the Ministry of Transport, where we could have the model SWIFT of the sustainable urban mobility indicators. We applied also surveys considering number of public transport passengers per year, the number of kilometers of passenger vehicles per mode, the satisfaction, the overall satisfaction level, etc. And on-field measurements, considering traffic flows, car travel time, peak hour and off-peak hour, and noise measurements in different districts of the case studies seen previously, and GIS data, considering the total length of bike lanes, total length of traffic calming roads, total length of pedestrian zones, etc. And when we had the first part of the methodology ready, considering that we collected this data, we needed to find a reason to put some weights to prioritize this sustainable urban mobility indicator, and we used as our methodology, as our core methodology, the structural analysis, where first we applied a literature review in order to see these sustainable urban mobility indicators, and we recruited a group of experts coming, there were 28 experts coming from different fields, such as geography, urban planning, transport engineering, accessibility and mobility planning, environmentalists, etc. Where in our first contact with them, we needed to explain the interlinks between these sustainable urban mobility indicators, considering the criteria of Sussman, and to connect these indicators with several public policies, so that to categorize these public policies and promote policy recommendations. At the end of this whole process, that is a heavy process, it lasted about 6 months to complete the whole workshop, let's say, with the elite, with the expert groups. We were able to generate this matrix where we can see the previously, the aforementioned indicators, both in row and in column levels. When there is an influence from an indicator at the row level to the rest of the indicators, we can put one to this intersection, let's say. For example, the affordability, it has an influence rate equal to 4, while at the same time, it has a dependence level that is translated in the column rate. It has a dependence rate equal to 0. So by that way, we are able to locate all of these indicators to these 4 sectors. The most important sectors for sustainable mobility, let's say, and for that reason, these indicators are the ones that have the biggest weight, are the opportunity of active mobility, traffic safety, and congestion, that is in the sector number 2, that at the same time are very influential and very dependable. So they need to be prioritized and treated firstly, so that to not generate instability to the whole system. And at the same time, sector number 1 contains these indicators that they are highly influential, so they can be used as something that can be forecast, let's say, the behavior of the whole system. In that case, we can find the multimodal integration, energy efficiency, and the accessibility of mobility service. At the same time, the affordability for public transport, as we can see, it can be located to sector number 4, that is the least important sector, but almost it is very close to pass to the next level. And considering that the affordability of public transport and public transport in general is a very important factor for sustainable mobility, it should be treated in a very important manner. About the modal split that we got from the 4 municipalities, we see that it's pretty predominant, the private car for Xylocastro and Nafplio. It can be attributed to the fact that it doesn't have a robust, solid public transport, while in the case of Neas Mirni and Egaleo is a little bit smaller. And at the same time, public transport in those areas are bigger compared to Xylocastro and Nafplio. Then we checked, we verified each indicator in terms of best value equals to 10 and to 0. And with that strategy, we generated a spider index that can be further normalized into these values, where in one part we have the scores as they resulted from indicators, calculators, and evaluation within the 4 case studies in the municipalities that we saw previously. And on the other part, we have the weights that they resulted from the actual structural analysis, depending on the influence and dependence rate. And by that way, we had the final value of each of these indicators. So, as an overall result, we can say that Egaleo is, in our case, is the best case, let's say, primarily because public transport is very strong in this area, along with Neas Mirni. And then follows Nafplio, and at the end, Xylocastro. As a conclusion, what can be said is that the sustainable urban mobility indicators can be characterized as as a data-hungry process. In order to complete the study, we needed about 8 months. Sustainable urban mobility indicators are highly dependent on modal split. The results, as we said previously, reveal the significant contribution of public transport and metro lines to those indicators. Nevertheless, only the public transport services does not guarantee the solution of traffic congestion problems. Especially here in Greece, the culture of private automobiles is very strong, and it needs supplemental measurements to be taken into account in order to have an important difference. The performance of energy efficiency indicator is poor in all 4 municipalities, and this is related to car dominance and oil dependence. And something oxymoron happened in the case of NAFPLIO because it performs best in the active mobility infrastructure, yet the associated environmental indicators are not significantly different from the 2 municipalities of Athens. This could be attributed to the fact that as they consider safe by that way, it is very low share of cycling and walking trips in this part. So, in fact, the people are not using this kind of infrastructure. And about the structural analysis method, as we said, the most influential factors, according to the opinion of the experts, are those related to traffic safety, air pollution, and congestions and road deaths. And to a lesser degree, the access to mobility services, as is capable to compete against private automobiles. As limitation and future research of this study, it would be intriguing to see how this hierarchy would have been if we would have considered the intensity of the direct relationship within the matrix, as in classic structural analysis implementation. We need to take into account not only zeros and ones, but also 1, 2, and 3, so that to calibrate intensity. These were the 2 published works that we were based in order to create this study. And thanks a lot for your attention. That was all from my part.